Hello, Professor. This is Catalina, and I'm gonna go over this week's assignment. So it was pretty simple. First, it asked us to find the Pearson correlation coefficient R, and they gave us basically all the values we need to easily just solve this formula for this case to find the correlation between variables x and variable y. So after replacing all the values, our correlation coefficient was 0.9 positive. So what does this mean? This means that there is a really very strong correlation. So variable x and variable y have a very strong to close association. And also that as variable x increases, variable y increases because it's positive. This also means that as variable x decreases, variable y decreases too. So yeah, here I give a little bit. It's important to remember correlation does not mean causation. Now we need to interpret and calculate R2. So R2 was 81%, which means that the variability in y, 81% of the variability in y is attributed to the variability in x. Nonetheless, here there are a few things that we need to keep in mind. First of all, that it works both directions, so we can also say that 81% of variability in x is due to variability in y. And yeah, so we need to keep that in mind. And yeah, there I explained a little bit more. And well, for the last one, the null hypothesis would be that the correlation coefficient is equal to 0, or that there is no association between the variables, which means that the observed patterns depart from chance alone. And then to test, we need the degrees of freedom, and in this case the degrees of freedom is n-2, so 23, and our critical value at a 0.05 level of significance with 23 degrees of freedom is 0.396. So as we can see, we can clearly reject the null at a 0.05 level because our R value exceeds our critical value. So we can conclude there is a strong statistically significant association between variable x and variable y of the study. And yeah, that was it for this week. Thank you so much, Professor. See you next time. Bye.